the MATLAB code I create for you, it is better that you put everything in the same directory, in the same file. So here under my document, I have a bunch of files, and I have one called MATLAB, and I have another one called under MATLAB called 2020 Summer Project. And in here I have several folders, but most of them are empty right now. I just have things in the folder called code. So here I have sphere, I have Swiss road. They are functions used to generate surfaces. And you will see another one that's called DMDemo, DiffusionMapsDemo, with non-corrected, what is this? Say, let's see. Okay, so DiffusionMapsDemo corrected for density, and DiffusionMapsDemo not corrected for density. So the not corrected for density is we choose alpha equal to 0, and corrected for density meaning I choose alpha equal to 1. So I'm gonna show you how to do this. Okay, so I open my MATLAB. Okay, so first thing you see is you have a file path here. So it's under the user document, MATLAB, and the summer project, and the file named code. Okay, so if I am not under the right directory, if I try to run the code, the MATLAB is gonna complain and say like, oh, do you wanna add the path and such. So the easy thing is you just make sure that you put the M files. This is .m, so the M files under the same directory, so then you don't run into issues about path. Okay, so let me double click the sphere. So now you can see the comments are in the color green, and my code is in black. So what I can do is I can either hit run button here, and it runs. So it runs the code I have in this script. And on the right hand side you see a window called workspace. So it tells you the variables I have when I'm running the code. Okay, so you see it generates a sphere. So I can do view, camera toolbar, and I think okay, so then I can what happened? How come it becomes 2D? Let me see. So scatter 3. Okay, so I can now rotate this. Oh well. Like that. All right, so that is one way you can run the code. You hit the button run. Another way you can do is in the command window, you can type the name of this function. So the file is called sphere, so I can type sphere in the command window and hit enter. Say okay, I'm gonna run this function. So this is what I get. Okay, like that. And you can rotate the images to see what it looks like. All right, and if I want to see what the let's say x coordinates are, then what I can do is I can just double click, and it shows me the x coordinate of all the points that I generated. Okay, so we have about 4,000 something points. Okay, and here, if you go through the code line by line, you can see that the phi division is a parameter that I choose to partition the angle phi, and the theta diff is the partition for theta. And I also have R naught, that is another parameter for radius. Maybe I should put the radius together with other parameters. So I first select parameters, then I use another function built in MATLAB to generate spherical data. And I use the formula for XYZ coordinate to generate the XYZ coordinate. And put this together, I call the huge matrix consists of the XYZ coordinates of these points, call them data. Okay, size of data is n, meaning number of points, and the C map is just for coloring. Scatter 3 is the function that prints out the cloud points, and I give it title called original data. Okay, so what you should do is you should play with this line by line, and you can try to say, okay, I don't understand what this mesh grid is. I can go to the search document, or can just click help for that. Okay, so it's gonna pop up, and you have the MATLAB document that tells you how to use this function. Okay, and then you can play with this. So there is no shortcut to learn MATLAB. The best way to learn is to play with it. So this is generating a sphere. And if I'm done with this, what I can do is I can say clear all the variables. So first, now you notice that we have several saved data variables here in the workspace. So when I hit clear all, they're gone. Okay, so now if I call the X or whatever, they are not there, it's being cleared. And if I want to clear the lines in the command window, I can do CLC, and I hit enter, so you see they're gone. Okay, so that's for generating function. Let me do this again. Okay, and I want to close this extra window, so what I can do is so let me show you. I have window called figure 1. Sometimes when I open too many figures, I have too many figure windows, I can do is use the command close all. It's gonna close all the windows, but I'm just closing windows, so you can see the variables I have in my workspace are still there. Okay, so you see that I have a variable called data, that is the information for our points. And now let me open the function DiffusionMapsDemo. Okay, so this demo and the other demo are modified by a code I found on the internet. So you can just Google search diffusion maps code, diffusion maps MATLAB code. You'll find something, and you can play with those code that you find too. Okay, so here I'm not generating data in this code. So I'm gonna use the data that I generated from the sphere. So you see I have data that I generated from the previous function, and in this new menu script, I'm gonna just assume that, oh, I have data. I know what data means. So now I can run this. So let me just hit run, and you'll go through what do we have in here. Okay, so it prints out several stuff. Okay, so this is using the third phi3 is the third vector, eigenvector, phi4 is the fourth eigenvector to do embedding. Put the sphere into R2, and this is what it looks like. And here we use phi2, phi3, and phi4 to do the embedding. So that's the one on the right, and you can see they are fairly similar, if not exactly the same. Okay, so you can kind of rotate it and see how it goes. And the one on the left is the original data. And so this is again a two-dimensional embedding. Figure 3 is a two-dimensional embedding using phi2 and phi4, as opposed to the previous one using phi3 and phi4. And figure 2 is phi2 and phi3, a two-dimensional embedding. Phi1 is the print for the original data. Okay, so now I know what's going on. So too many windows. Let me do close all. Okay, so you can see they're all gone. They're gone. I closed all of them. Okay, so so suppose I wanna just comment some functions, so then they are not being used. So here, this is the line that does a lot of two-dimensional print. I can just comment it. So now MATLAB will ignore these lines of code. If I hit run again, you see I only have the print of the original data and the print of the original data and the three-dimensional embedding. Okay. All right. So let me do this. Okay. So what if I didn't generate the data first, and I just hit run in this code? You can see it says unrecognized function or variable data, because I'm using the variable data but without defining it. So this function does not know what data is. Okay. Therefore, we need to generate the data first. So let me use a Swiss rule to generate data. Okay. So this is what it looks like here. Now you see I have data. I know what data is in the workspace. I have that variable. So if I now run the DiffusionMapsDemo again, you can see that the three-dimensional embedding looks like this. So the Swiss row is being kind of flattened as opposed to what it was before. Okay. So what you need to do is to go through these commands and make sure that you understand how this corresponds to the algorithms in your reference papers and the diffusion map or Laplace eigenfunction maps, the papers by Belkins and Niogi, or papers by Koifman and Lafont. Okay, so that's the two examples for generating a manifold and the run diffusion map on the generated surfaces. Okay, all right, so that's what you're gonna do.